our lesson of today. Infer changes in speed or direction resulting from forces acting on an object. Basically, we are going to be learning about force and speed, and then how that changes, how the speed changes according to the force applied to it. And also we're going to be comparing the relative speed. I mean, how faster or how slow an object goes depending on the amount of force it applies to it, and also the distance that object can go based on that force applied to it. Let's start with the definitions and some pictures or illustrations so you can see what are we talking about and have a better idea what it is so far. You can see a child pushing something, and you can see this dog on this picture pulling something. Basically, we have push and we have pull on one side. Okay, what is pull and what is push? Based on our definition, we have push and pulls are forces that can change the motion of an object. Basically, depending on if you push or you pull something, that object will go based on the or will move, or the motion will be affected by the force you apply to it. Now let's talk about forces. What are forces, or what are force? Or what is a force? Push and pulls are forces. That's a fact. Force can start, can stop, or can change the direction of an object's motion. The force you apply to something can determine where it's going. All motion begins with a force. An object cannot move unless a force is applied to it, or unless force is applied to it. In the pictures, as we were saying before, the boy is making boxes move by using a pushing force, and the dog is making a wagon move by using a pulling force. Depending on the force applied by the child, that box will go in that direction, and the same with the dog. Depending on the pull force the dog applies to that wagon will go in that position too. Force and motion. What is the difference between force and motion? How are they related to each other? How are they determining the direction or the speed of an object? The motion of an object can be changed if it is pushed or pulled. The motion or the movement of an object can be affected depending on the force you apply to it. Whether you use a pull or push force, that will determine how far or where is that going to move, or where that object is going to move. When something is pushed, it will move away from the thing or person that pushed it. People might push swings, toy cars, or buttons. When something is pulled, it will move closer to the thing or person that pulled it. People might pull on strings or wagon. When you push, things go away. You can see that here is pulling, is pushing those kids in that swing. So when you push something, things goes away from you, and when you pull it, it gets closer to you. That's what it is about. So you can see these kids here pulling this wagon, so it gets closer to them. You can see them here. When you pull things, move closer to the thing or person that pulls it. That's what is this referring to. We're not going to watch the video because that's not the purpose of this. Let's go to our next slide. What is position in objects? That's our big question. Position. A force can change the position of an object. The force can change. The force you apply to a ball, it can affect its position when you throw that ball. The picture below shows subjects changing position. The boy is changing the position of a ball from his hand to the air. He does this by using a pushing force when he throws the ball. When he throws the ball goes away from him or far away from him. That's what we learned on the slide before this one. The girl changes the position of the tennis ball when she uses the racket to push it away. The same with the girl. When she pushes that ball with the racket, that ball is going to be far away from her depending on the force she applies to the racket. That ball can go faster or it can go slower. It can be further from her or it can be just very close to her depending on the force she applies to the racket, and that ball will be affected by that force. Speed. How does force affect the speed of objects. Speed. A bigger force can make something move faster than a smaller force. A bigger force can make something move faster than a smaller force. More force you apply to something, that will move faster, and less force you apply to it, it will be slower. Speed is how fast something is moving. It's very important here. A bigger force can move an object with more speed. That is a fact. More force you apply to something, and that will have more speed. Less force you apply to it, so it'll be slower. Using bigger pushing force when skating will make a person move faster. Pushing harder on a pedal will make the bike move faster. Now let's talk about direction. Direction is where an object is moving depending on the force applied to it, and also the direction will depend also on the speed. A force can also change the direction something is moving. The picture below shows a soccer ball. The yellow arrow shows the starting direction of the ball. The orange arrow shows the direction of a pushing force that is used on the ball. In what direction will the ball move after it is pushed? Well, that will depend on the force you put, so it will move on that. The ball is moving downward and is pushed to the right. The ball will keep moving downward after it is kicked, but it will also move to the right. The picture. Well, we are not talking about the box right now. That's because that's not our main focus in this lesson. This part will be discussed later. Which statement is true? An object in motion must always go straight. That's option A. Option B. An object in motion might change direction. Option C. An object in motion might be sitting still. An object in motion must always change direction. An object in motion must always go straight? Not exactly. That would be depending on the force applied to it. An object in motion might change direction? Well, also it can. An object in motion might be sitting still? No, that's not possible, because the force you apply to an object will make that object move faster or slower. An object in motion must always change direction. I'll pick option B. Next question. This is part of our guided instructions. During a baseball game, some batters hit the ball a very long distance. Other batters hit the ball only a few feet. What is the main reason that the ball travels a different distance for each batter? You have to remember that depending on the force you apply to the ball or to an object, that object can go faster or it can go slower. Let's see what are our options here. Some batter hit left-handed and some hit right-handed. That's not true. Being right-handed or left-handed doesn't affect how fast the ball goes or how slow it goes. The color of a bat, the color doesn't have to say anything on that, and that will affect visibility, but not the speed of the object. The ball travels farther when the sun is in the ball's eye. Wow. The batters hit the ball with different amount of force. That is true. Next, Anna is pushing her brother on his swing. Anna pushes her brother again in the same direction that he is moving. What will happen to her brother? Remember, when we push objects goes far away from us. When we pull in, they come closer to us. And also, the force we apply to the object will determine how far or how close, if we pull in, that object will move. He will stop swinging. That's not true, because if you pushing someone on a swing, he will be always in motion, moving. He will swing faster and higher. Same direction that he's okay. This might be kind of like what we're looking for. He will slow down and then speed up. He will start swinging in the opposite direction. So we can pick this one as our correct answer, and we cross out these ones. Okay, that is independent work. Okay, read each of these exercises. Read the problem. Remember our lesson. You can go back, pause the video, go back to the very beginning where you can see the explanation about force, direction, and speed. That will help you to answer these questions correctly. Second independent work is your turn to show what you know, show what you need, and show you learned this lesson. And That's it. Thank you.